This is a video on inverse matrices. So let me just give a quick little background that if A is a matrix, 2 by 2 matrix with A, B, C, D as the elements in that matrix, then A inverse is this. It's 1 over the determinant, and if the determinant is 0, then the inverse doesn't exist. It has to be non-zero. So the determinant is A times D minus B times C. And so 1 over that, A D minus B C, is the scalar quantity that you would multiply the following by. Now A and D, these two get switched. And so D goes up and A goes down. And these two get switched. They stay in their position, but they switch signs. And so this one, it becomes the opposite of B, and this one's the opposite of C. So whatever those signs were, they switch. So you multiply that all out, and this is what your inverse looks like. Look at this as an example here. So first off, the determinant, again, let's call this A, just because it's a nice thing to go to, A. So the determinant of A then is 4 times 6, subtract 7 times 2. And this is 24 minus 14, and 24 minus 14 is 10. So from there, the 10 then becomes 1 over 10, 1/10, times, remember these two get switched, and so 6 comes up, 4 comes down. These two, their signs get switched, and so this becomes -7 and -2 in those spots. And so now we just do that multiplication. And we'll go ahead and simplify to make our lives a little bit easier. So 1/10 times 6 is 6/10. 6/10 simplifies to 3/5. 1/10 times -7 would be -7/10. Will not simplify. 1/10 times -2 is -2/10, which is -1/5. And then 1/10 times 4 is 4/10, which would be 2/5. And so this then is A inverse, the inverse of A. Done. All right, so on this next one, it says use your calculator to find the inverse of the following 3 by 3 matrix. So here we're going to plug it in. I'm going to grab my calculator, I'm going to clear the memory, and then hit second matrix. I'm going to move over to edit. I'm going to call that first matrix A, well, the only matrix A. It is a 3 by 3 matrix, so that opens up 3 by 3, 3 rows by 3 columns. And it's 2, 1, 0 in the first one, 2, 1, 0. And then it automatically moves you to the second row. 1, 2, 1, 1, 2, 1, and then 0, 1, 2, 0, 1, 2. And now we've got our matrix entered into the calculator. Then I can do second mode, quit. I'm going to go back second, just choose that, and it brings it to my main menu. And we want the inverse. And so that inverse is that button, which is x to the -1. So that's what we're going to use. And so we just press that button, gives us the inverse of A, and then we just hit enter, and it gives us these values. So 0.75, I'm going to copy them down. 0.75, negative 0.5, negative 0.5, 0.25, next row, negative 0.5, negative 0.5, 1, negative 0.5 again, 0.25, negative 0.5, and 0.75. Now, if we want our answer as a decimal, then we go with that. If we would rather have it as a fraction, then I can hit Math, Enter, Enter, and it'll take each of those and convert it into a fraction. And I won't bother writing that one down, but that's how you would get it if you want a fractional answer on your inverse. Okay, let's go. So on this next one, it says solve the following systems of equations by hand using the inverse. You must show your work. Do not use a calculator. So I would take this system of equations and translate it into a matrix representation. So I've got 4, 7, 2, 6 times x, y, and all of this is equal to another 2 by 1 matrix, 18, 14. And so if I call this capital A and this capital X and this one, let's say B, then our goal is to multiply both sides by the A inverse. And over here, this cancels out because it gives you the identity matrix, which when you multiply by X just leaves the X alone. So that's how we cancel this. On the right, this gives us the answer. So we are fortunate to have already found the inverse for 4726. 4726 we found up here in this problem here. So we're going to use that. I'm just going to copy it down. 3/5, negative 7/10. 3/5, negative 7/10. And then negative 1/5 and then 2/5. So negative 1/5 and 2/5. And so really all we have to do then is multiply as we showed right here. This is our answer since this part is just going away. We don't really have to show that. We can just say that x is the inverse of a times b. So I'm going to take 3/5, negative 7/10, negative 1/5, and 2/5, and I'm going to multiply it by 18, 14. And so I've got 3/5 times 18. 3/5 times 18, and I'm going to add that to negative 7/10 times 14. And then down here, I've got negative 1/5 times 18, and I'm going to add that to 2/5 times 14. And that is my answer. I just have to, simplify it. And I can do that. I can do that by hand. I can also use my calculator. So I'm going to use my calculator. 3/5 times 18. I'm going to take, I'm going to use the fraction button up here. 3/5 times 18. 3/5 times 18 plus negative 7/10 times 14 plus I'm going to put the negative on there. Negative 7/10 times 14. Just double check to make sure that's what I had. And then I just hit enter, and that gives me 1, which is great. So over here, this is 1. And then I'm going to do it again on the bottom, negative 1/5 times 18. Negative 1/5 times 18 plus 2/5 times 14. 2/5 times 14. And that gives me 2. And so my answer here, x is 1 and y is 2. All right. All right, on this next one here, it says use your calculator to find the inverse of the following system of equations. Then use the inverse matrix to solve for x, y, and z. So first off, we want to translate this again into kind of a matrix system. This time we get to use the calculator. So I can go 1, 1, 1. Spread that out just a little bit. 1, 1, 1. 2, 3, 1. And 3, 2, 4. That gets multiplied by x, y, z. And that's equal to this matrix 6, 11, and 19. So I'm going to use my calculator to find the inverse. Just clear the memory here. And go matrix, edit. It's a 3 by 3. And the top row is 1, 1, 1, 1, 1, 1. The next row is 2, 3, 1, 2, 3, 1. And the bottom row is 3, 2, 4. 3, 2, 4. And then I can go second mode quit. Second mode matrix. Just select that. And then we'll take the inverse with this button here. And then we hit enter. This says no inverse matrix exists. Calculate a result not found if dependent on a matrix inverse. All righty.